Cool. So yeah, welcome everyone to the Marquez community meeting for July. Last month in June, we talked about what's coming in 0.16. So in this meeting, we're actually going to do some demos of some of the features that made it into 0.16. So with that, yeah, let's just get into the agenda. So we'll talk about 0.16. I think some of the highlights. We'll go into the quick. We'll do a quick status update. So we're currently migrating the Marquez integrations to OpenLineage. So we'll give you a status update there. And actually, some recently good news. It was just announced today that OpenLineage is part of the LFAI and data. So pretty exciting news. I mean, that shows, I think, the momentum of the standard, and the fact that Marquez was part of that story, I think is great. But the community is only going to grow, and Marquez will benefit, I think, from the integrations that will be developed in the OpenLineage repository and by the community there. And then we're going to end with, I think, some exciting demos. I'm going to give one. I'm going to do a quick walkthrough of our Lineage API. So how do you query Lineage metadata with the Lineage API, which has been moved from beta as a top level API. So part 0.16, we kind of said, hey, we're pretty comfortable with the API spec and in terms of its performance. So we made that a top level API. And we're gonna have Mike, who's gonna walk us through the JobVersion API. So that's a new one. We've always had the dataset version API, which allows you to view changes within the schema. But now I think there's a lot more exciting things, which I won't talk too much about, just because I don't want to steal your thunder, Mike. But it's a really valuable API that we exposed in 0.16. Okay, so new features which we already, I kind of highlighted the Lineage API. So this one's, the reason why this is exciting is that currently the front end, or I'm sorry, the Marquez UI, it's not using the Lineage API. We're trying to simplify how the UI loads right now. It's storing a lot of it in memory. So when you first load the UI, it actually fetches the namespaces and the jobs and then the inputs and output data sets. So a lot of that's actually managed in memory in the browser. And that was just the initial version of how we did it, because we didn't have this slick Lineage API. So we're going to be transitioning over to transition the UI into using the Lineage API. And at that point, it's going to be a lot more responsive. So as your jobs are updating its state and also its metadata, you're going to be able to, the UI will be able to update in place and maybe just update a subgraph of the Lineage graph rather than having to load everything in memory, which is currently what's happening. So if you want to find more details on, the implementation and the discussion around the API, you can check out PR 14.5.7. And the other one is just the JobVersion API. This is something that Mike, you added. If you want, you could add some details to this, or yeah, if you want to talk a little bit more about this.
Yeah, I could talk more about it in the demo portion, maybe.
Okay, great, yeah. There was actually there was a blog also that Mike, you wrote that's in the OpenLineage website that uses the JobVersion API as well, which I think was a forcing function to get that API out. And then the other one, we did start some work on the DBT support for BigQuery and Snowflake with OpenLineage. So they were a bit experimental for the most part. So it's the initial version, and we're kind of looking for the community to try it out and give us feedback on maybe some bugs that you find. Okay. So actually, this is the current status. So we started moving the Marquez Airflow integration to OpenLineage. There's a PR out, so that's in progress. And the Marquez Spark that actually just got merged in this morning. So that's complete. The Marquez integration common, so that is what stores a lot of the common code used by a lot of the Python integrations. So that's been moved over to OpenLineage. And the two that is going to happen this week, we're going to be moving over the DBT integration. So that's currently in progress as well. So I think the idea is we're going to wrap things up in terms of moving all the integrations over and then cutting an official release, or OpenLineage will cut an official release shortly after that. And then the integrations will be deprecated in Marquez. I think, so the good news is that it's all gonna be backwards compatible. So even though we're kind of making this huge effort to move the integrations over, things won't break. We're gonna make sure that, if you're currently using the Marquez packages and you want to transition over to using the OpenLineage artifacts, that your Airflow integration won't break and you have time to transition over. And that's kind of all I had with in terms of like updates here. I'm not sure, Julian, if you had any updates that you wanted to make on OpenLineage or anything like that with the integrations.
Yeah, the goal is to move quickly to a 0.1 release of OpenLineage. And so finishing moving in the integration, there are a few small tweaks to the spec happening. And so feel free to comment on OpenLineage there. But otherwise, we're on track to make 0.1 soon.
Okay, great. So what I'll do is go back to the agenda. Okay, so I'm up first to walk you guys through the Lineage API. Let me see what I got here. Open. Exit out of this. Cool. Oops. I have too many windows open here. Okay, this is the one I want to exit out of that. Okay, so I have a fresh instance of Marquez running. So what I was going to do is use the OpenLineage as a guide. I'm sorry, I have to make some. So the OpenLineage website comes with a getting started guide, and it uses Marquez as a backend. And there's a few API calls. So I'm not sure if you've guys seen this, but with the new OpenLineage website, it gives you some details on how to get started, and it uses Marquez as a backend. So essentially, you just have to do a start run and then a complete run in order to get the lineage graph. So what I wanted to do is just kind of walk you guys through that and explain a little bit more about what the Lineage API returns on the Marquez backend. And there's some kind of do similar things where you're exploring the UI, but not go too in depth in the UI, because the more exciting part is how the API works. So we'll transition here. So what in the blog, there's two calls that are made. So I kind of just saved them here, and I'll zoom in. So with Marquez, it's going to expose the lineage endpoint, and the one thing I actually forgot to do, I'll show you guys. We've documented how to get a graph, and which we'll do in a little part of my demo. But in order to actually ingest events, OpenLineage events into the Marquez backend, you just do a post to a lineage endpoint. And as long as it follows the OpenLineage standard, so here, if you look, we have the type, the event time, the run with the run ID, and that's what's going to be used to stitch together all the different event runs or all the different run events that are posted. You'll have the job metadata associated with the run, as well as any output data sets and their facets. Okay. So what this is doing is really just doing an example. It's kind of we're going to do a start event. We're going to have Marquez running on localhost port 5000. And I'm going to give it a start event. I'm going to give this run ID, and it's just a randomized UUID with a job, namespace name, and also an input just called my namespace with my input. Okay. So, okay, registered that. So I do a refresh here. Cool. All right, so we got my input, and if I do a search here, you'll see that I have my job. Oops. And it's currently in a running state. So since I posted an OpenLineage event with a running state, and I told it, hey, this is going to be my input, I haven't yet registered my output data set. So all you really get is this input and output. I'm sorry, just this edge where you have my input pointing to my job. And there's no schema. I didn't post the schema facet, although you could. When I do the next call, you'll see that I'm going to post the schema facet for the output data set. Right. And what you can do at that point, go here again. And just to kind of capture the current state of the Lineage graph, I'm going to do a curl on localhost again, just the Lineage API exposed by Marquez, but this time I'm going to do a get rather than a post, and I'm going to give it a node ID. And the node ID is going to be either a data set or a job denoted by a colon, and then the parts are going to be the node type, the namespace, and also the job. So if I just do a quick query, you'll see that currently the graph itself that's returned, it has no inputs or outputs yet, and because the job has to complete in order to register a dataset version. But you should see, oh wait, no latest run. Okay, so that's not registered. Okay, that's interesting. Let me do a post because that's gonna work. I'm gonna complete this. So the event type is now complete, and still it's gonna be the same run ID. I'm going to not provide the input data set because I don't need to provide that because the events themselves are associated with that run ID. But this time I'm going to use the namespace, my namespace, the same one. They're all within the same namespace. But my output data set is going to be called my output. And the schema, I'm going to give it the fields property, and you have the name and the type. So really, what's the field name and what's the field type? So here we have A, B, and they're both varchars. So if I go back to the UI, refresh here, and I type in my job, you'll see that we have a very simple but complete lineage graph. So the my output data set doesn't have a schema. We have my job. In this case, you just have it within the namespace, and my job, there's no schema, there's no SQL associated with the job itself. It's just really just the name and the input and output data sets. But when you click on my output, you'll see that now we have the schema. So you have the A, in this case, we had a column A and B, and they're both varchars. Okay, so I'm gonna try that API call again, and I'm actually gonna open up a bug about this because you'd expect the latest run, or actually the latest run should be null because the job didn't complete yet. That actually makes sense. Okay. So I'm gonna run this again, and now you do have a complete lineage graph. So if we go back up here, you have my output data set, and here, if you look at what's returned, you'll see that the call returns back a graph with an array of nodes. So every node has an ID, and you can see here we have the data set ID for that node, and here's the data set type, and this is for my output. Okay. Yeah. Let me say actually something. There's my job. Okay, sorry, yeah. So here's my output, and also here you see the schema associated with the node itself as well. For some reason, I'm sorry, I think I said output here. This was my input. I got a little confused because there's no fields. But yeah, this is the input. So the input data set didn't have any fields, but you can see that the origin and destination, so it doesn't have any in edges because there's no, this is the outer node of the graph. So there's no in edges, but the origin and destination, those are present. So this is saying that this node, which is my input, so it's a dataset node, is pointing to my job. So the destination is the job. And similar with the output dataset, you'll see that the origin is going to be the job. So in this case, the job is what really is creating that dataset or writing to it or modifying it in some way. And the destination is going to be my output. Now, if you look at the job node, it's going to be, in this case, it defaults to batch, but there's a streaming job as well that could be set depending on the type of job that is processing the data. So it could be a streaming job. And we have things like when it was created, updated. So a lot of the payload itself really represents what you see when you call the jobs API or dataset API. What we're doing is adding some additional things. So here's the latest run. This is the input versions and output versions. I won't go into that because that's something that Mike will be going into that outlines how we begin to track changes to a data set at the run level and how versions are created. But that was part of the work that Mike did in the JobVersions API. So here you'll see that you have your state, it's completed, some duration, so a lot of interesting metadata there. But the real focus is really going to be the in and out edges here. So here you can see the origin is going to be my input, the destination is my job, and the origin is my job and destination is my output. So if we go back to the graph here, so like I mentioned, the UI is currently still crawling the APIs to kind of fetch this metadata and load it in memory. But now we're going to be using the API itself, Lineage API itself, to build the lineage graph. So that's on our roadmap and it's coming. I'm not sure. We're definitely going to be starting work on it, and it's on our roadmap. And I think we're working on prioritizing integrating the Lineage API into our front end. And that's kind of what I wanted to walk you guys through. Let me see here. Yeah, that was pretty much it. But anyone have any questions on those? Okay, cool. Well, hopefully that was helpful. You can always go to the spec and take a look at the Lineage API and see how you could record a lineage event using the OpenLineage standard. And then same thing with the graph. Once it kind of goes in detail about what the payload looks like. So exactly kind of what I walked you guys through, but here we just have some example request responses and also the format of the response itself. Okay. Cool. So next, Mike, yeah, if you want to take over, so I'll stop sharing and you could walk us through the JobVersion API that made it in 0.16.
Sure. Yeah, you know, and I think it's worth probably just mentioning again that so both of these changes have accompanying blog posts. So Willy has a blog post here on the OpenLineage site demonstrating using the same Lineage API he just walked through, specifically for the backfilling use case. But yeah, so check out the blog for specific details on how the Lineage API is constructed. And then similarly, I have one exploring the JobVersion API with the dataset version API. And both of these have steps that you can kind of walk through yourself. So check out the project, spin it up using a Docker image, and then kind of play with the APIs. I just thought that was worth kind of pointing out.
No, yeah, thanks, Mike.
Yeah. So and the demo here that I was going to show is basically a walkthrough of what's already in the blog post. So I have a running version of Marquez just using the Docker image. And I seeded it with the example data. So, you know, we have the kind of classic food delivery sample that we use all the time. And so that's the data that's seeding this instance of Marquez. So if we take a look at, so the existing jobs API, so here we're going to look at just the list of existing jobs. the data is mostly the same as how it was before. We have, kind of the job ID and the all the metadata associated with the job. But we also have the latest run, and the latest run now has a few additional fields in it. So one of which is the job version, which is, gives the specific version of the job that was associated with this particular run, and also the input and output data set versions. So previously, I think the runs included the list of, I think you could get the list of data sets, but you couldn't get the specific versions that were associated with those runs. So you couldn't see which version of the data set was read by a particular run, or which version of the data set was written by a particular run. So these are both included now. One of the things that we've talked a lot before about Marquez is Marquez has this kind of classic use case of being able to debug the cause of failures, right? So like, you have a job that's been running for months and it hasn't had any problems. And then all of a sudden one day the job fails and you need to figure out why. And so like we have this kind of classic example of, oh, somebody accidentally changed the schema of the data set from, they changed that B column from a varchar to an int and didn't tell anybody. And so now all of a sudden, all the downstream jobs broke. And one of the things that we kind of realize is that just using the existing version APIs and the run API, it's pretty hard to actually track those kinds of changes and be able to diagnose those kinds of failures. So kind of the impetus behind these changes was to make that concrete use case much easier to follow. So in the blog, we have basically that use case. And so what we want to do is, let's say this particular run here actually failed. And so we want to diagnose that failure, figure out what was the cause behind it. So given the fact that we actually have a job version that we can look at, we can actually query the job. And let's see. Yeah, so what we can actually do is let's look at the previous runs and figure out, okay, oops. Yeah, so we have the whole history of runs for this particular job now, and we can kind of see what the state for each of those job runs was. And the state for the most recent run has failed, but if we kind of scroll down a little bit, we can see that the state of the previous run was completed. And if we kind of looking visually, we can just see like the job version here is this E9 EAF job version, whereas the previous one that succeeded is this 92 D801 value. And so we can see that the job version has changed between the last successful run and this most recent run that actually failed. So I'm just going to copy some of the commands here that I have in the blog for getting the run IDs that for the successful run and the failed run. And so now if I want to, so we've kind of already looked at the specifics and seen that the job versions have changed. So, and actually this is just a diff way of doing it. So on the command, you can kind of see again, right? This is the job version that succeeded or that failed, and this is the job version that succeeded. And you would be able to tell just by diffing the two runs that there is a difference between the two. So now we'll get the failed job run and the successful job run, or job version, I mean. So now if I want to see more about this job, I can hit the new job version API. And so this is very similar to the jobs API, except that we now have versions, and then we can specify the actual version ID here at the end. And if I just pipe this into JQ, We have a nice format. So we can see, okay, this is very similar to the response from the job API. We have an ID, except the ID now has a namespace name and a version. And then it will have the specifics about that version of the job. So like the location in GitHub, if that has been posted as a facet, we'll have the context of the job. So the specific SQL maybe that was executed. The inputs, so the data set inputs and outputs are not versioned. And that's because, you know, a single job version exists across multiple runs. And so each run consumes or produces a distinct data set version, but that job version will consume and produce many different versions of the same data set. So the data sets in the inputs and outputs here are not versioned. And then we can see the latest run that was associated with this specific job version. And here in the run, you can see again, right, we have the job version, it's still in the response, and the data set here is versioned. So this is the specific version of the data set that was consumed by this particular run of this job version. And then if I was to look at the last successful job version, I would see basically the same information, right? So the inputs and the outputs are here. The SQL, the GitHub location, and the latest run that's associated with this particular version of the job. So now if I want to do a diff, I want to see what are the differences between those two job versions. So I'll delete some information that I expect to be different, right? Like, so the job version ID is obviously going to be different because the version itself is different, as well as the version field. The job versions were created and updated at different times, and the latest run is going to be different between the two. So I'll delete those for the sake of doing a diff. And here I can see, and maybe notice when I was just showing it manually before, the failed one actually has 0 outputs, whereas the successful run has a list of outputs. And this is kind of one of those cases where you actually expect that to happen because the job failed. Because the job failed, maybe we don't have insight into the data sets that were supposed to be created by the time the run information is posted. And so maybe we just weren't able to post the information about the outputs of the last job run. So that in this particular case, it actually doesn't tell us a whole lot. So we might look at instead, but since the input and the output data set versions are in the API, and I'll kind of show that again here. Yeah, so since we have the run information and we have the specific input and output data set versions, we might be able to actually look at the last version of this data set and what job is upstream from that data set and actually produce this version of the data set. So we can do another diff here. Shoot. There we go. So here's the difference between the input data set versions and the output data set versions. Don't have those remedies. Here's the remedy. Probably do that. And don't show a difference here. All right, so I can do this manually then. Yeah, so if I want to get the data set versions, I can just query the existing data set versions API, and that would give us information about the data set itself and actually what version, which job version created that version of the data set. And here we are. I just need to copy this UID and then copy this command here. There we go. Please, I probably did I not copy the right data set version? That's right.
There's the.
Oh, that's I copied it.
Yeah, it's you're querying the jobs API.
Yes, you're right. Mistake.
Yeah, it's
Let's see. All right, let's try this one. Okay. All right. So sorry. So this is the previous. This is the upstream job, I believe. So the job that created the version of the data set that was consumed. Nope, this is still the same. This is the same. Yeah, I'm having some trouble following my own blog. I missed. I think I skipped a command earlier on. But yeah, so basically, what we'd want to do here is copy the latest run for this job, or for the latest run of this job, and I believe we just have to skip all this, and then is it runs / and then run ID, right?
It's jobs / runs.
Jobs / runs.
Yeah.
There we go. And then here I would see, so the, so this is, oh yeah, no. So what I want, what I still want is the data set. Let me find the command for the data set, the upstream data set version. Job runs, here we go. Here we are. This is the, and now I can get the data set version. All right, this is what I was looking for. Sorry. Anyway, so now I can see the specific data set version. And then in particular, so I can see the run that created that version, that data set version. I can see all of the input data set versions that were consumed by that run, and then the output version, of course, is this particular data set, but there might be other data sets involved. But yeah, so from here, I can see the specific version of the job that actually created this data set. I can do some things like compare the schema of this data set along with the schema of the data set that was created by the last successful run of that job version. And if you kind of follow along in the blog and do copy and paste all of the steps, don't skip steps like I did, you would be able to see that, this particular version of the data set actually has a slightly different schema than the version of the data set that is consumed by the last successful run. And then if you looked at the job versions that created the two data sets, you would see that there's actually a different location in the job version. So the GitHub location of the job changed between one version and the next, which kind of implies that there was a code change, and that code change caused the output schema of this particular data set to change from one version to the other. Like I said, if you copy and paste all the instructions in the blog and don't skip any steps, you'll be able to see that just by using kind of diff and curl and JQ altogether. Yeah, I think that's pretty much it.
Michael?
Yep.
Just for my, I know you mentioned the blog post. Is there a way you can copy the link to the blog post so I can just jump to the right one?
Yeah, absolutely. So I can post it in the chat here. But if you go to openlineage.io, there's a blog menu item at the very top, and like I said, both of the Lineage API, the backfilling with the Lineage API, as well as this particular use case are on that blog. But I went ahead and posted it in the chat, so if you guys look in the chat, you'll be able to just click on the link.
Nice. So, Mike, thanks for the walkthrough. And yeah, so as you can see, you know, just in terms of how the Marquez APIs have progressed, they're becoming a lot more useful. So those two blogs that Mike mentioned around doing backfills with Airflow using the Lineage API, but also troubleshooting why my job is failing in general, and understanding what run produced what dataset version. That's just the beginning. So, you know, where we kind of want to see this, where you can kind of take this is if you want to develop internal tools. If you just want to leverage the REST API for Marquez, you could actually define your own tooling that allows you to see, okay, here's my job. I want to know what are the what happened upstream, what a list of versions of data sets that were created by a run that failed. So there's a lot that you can do here. This is just kind of the beginning. What we're starting to see is the APIs are becoming a lot more useful, and possibly something you can use within your data team at the org that you guys are at. So.
Do we have time for like a couple of really basic questions?
Oh, yeah, absolutely. We have definitely time for that.
Okay, thank you. So my question is, so the dataset version and job version, what process sets that version? Is that Marquez or is it the client that I use?
Very good question. It's actually Marquez. So Marquez has two functions that are, so when you post an OpenLineage event, the way the dataset versions happen is one, if the schema changes, Marquez will detect that. And so if you add a column, remove it, change the type, Marquez will create a new version pointer and point it to the latest, and it'll keep track of all that. The other one is if you post a run event, so just like Mike showed, if you post a complete event, the run itself, actually Marquez assumes since the run was complete, I'm going to go ahead and create a new version of the data set because it's either has been modified, it was touched in some way. So there's assumptions that are being made there. So that's another way that a data set can be versioned. Now for the jobs, that one's a little different. So the way a version is created is that when a run completes, it will create a version for you. So, but what that means is if your inputs and output changes, Marquez will look at that and be like, okay, you've added a data set, you've removed it. We'll version it for you. And also the source code. So if there's that link to GitHub or whatever version control system you're using, if that URL changes, Marquez will do a version for you as well.
Yeah, and something that actually I called out on the blog is, we actually have an item, an issue that we need to fix in Marquez because the way, right now, if the job fails and we didn't write any output data sets, it's going to treat it as a separate job version. And that's kind of that, that highlighted in that first example. So that's actually, we have a spec to change that. And we have a more precise specification on when to bump the job version. And one of the cases that we considered is if a job has failed and didn't write any output data sets, then we're going to assume that we just didn't capture the output data set information, and if the GitHub location itself hasn't changed, we're not going to bump the job version. Of course, if the GitHub location changes, regardless of the state of the job, we're going to create a new job version.
Yeah. So to get back to your question, is kind of the version UUID is generated by Marquez, but it takes into account information provided by the client, like the GitHub SHA, for example, is taken into account to create a new version, and the metadata will contain that version.
Yeah, and it's a very good question because I think we haven't done a good job. As I was describing, I realized that should be in a doc somewhere. But the thing is, the first version of Marquez really was, we wanted to make that versioning transparent to the caller. You should just be sending metadata as it's updating, and then any sort of changes that are happening, Marquez would do that for you. There's also been discussions on maybe having the caller provide a version ID, or being where the caller can tell Marquez, hey, create a version for me because I know something has changed, rather than Marquez making some assumptions. But those are in the early phases of discussion that we thought about. So yeah, Victor, does that answer your question?
Yeah, thank you.
Did you have any others, or?
No, actually, that was you kind of covered it all.
Okay, great. Great question.
I have a few similar stuff. First and foremost, thank you for conducting these. So it's my first time attending this. Last time I missed it by a day. So I would look forward to this one. So here is a problem that I'm using. See, I want to use this as a tool from the tool that I'm building. So I'm looking at Marquez OpenLineage as an infrastructure on which I'll query. There are about 3 questions I need to answer for what I'm looking for in my whole ecosystem. And I'm saying that data pipeline ecosystem as an ecosystem where there are many people working on it. Sometimes they don't know who else is working on similar things. So a simple question I want to answer is, what are the input files that are coming into this process, and who's generating those things? So is there some way of reusing? Because if I can see a schema, I want to see it. I think one of your use cases had that, that Jillian or some lady was, Julie or Jillian, went and looked for that, and they said that some other person was already using that file. So I want to be able to answer those questions. That's one thing. And the second thing is, when I say a job, I'm still confused, but I'm looking at the word. Is this equivalent to a DAG, or is it to a task within a DAG? So are you going to a second level of granularity? And that was my second question, because I want to see how the transforms are being done. And third is, who else is dependent on my file? If I'm generating this output downstream. So these are the questions I want to answer. And looks like from what I read from what you're doing, it can be done. So thoughts and suggestions and how I can proceed on that.
Before we get into specifics, can you tell us just quickly, like, what's the infrastructure look like? Like, are these Airflow DAGs and Spark jobs or BigQuery jobs or that kind of thing?
So at present, I'm working at a company called BMC, and they have their own orchestrating tool called Control-M. So, and that is not too dissimilar to Airflow, but it works in a different arena. And that's my thing. And personally, there are 2 hats I'm wearing, though I'm wearing 1 hat. The second hat is, I want to build this as a demo tool for an Airflow thing. So if that is my personal hobby. Now I need to convince my management to see we can use this for Control-M as well. So I don't know the legalities and all of the other things, but if I were to just leave those things aside, these, for me personally, Control-M, but for work professionally, that is the one.
Okay, yeah, so you had 3 really good questions. I could answer the second one, which was around in a DAG. So in an Airflow DAG, what is a job? Is it the DAG or is it the task? So the way Marquez views a DAG is that it contains 1 or more tasks which are mapped to jobs. So jobs are going to be the ones that actually do the computation. So it's going to, usually when you define a task, you say, I'm going to use a Postgres operator. So you're going to have some SQL, right? So that's going to be a job in Marquez.
Okay.
So, but the DAG itself, I mean, really, it's just to show dependencies. So when you actually post that metadata to Marquez, it's actually stitching together the lineage graph across all the different tasks within the DAG, right? So you get that inter-DAG dependency. So that's the second. So let me know if that answered your question, but that's how Marquez views it.
Okay, let me rephrase it, what you said, and see if I understood. You are tracking it at a kind of quote unquote on task level, which could be an operator or whatever. But you're also tracking the DAG level dependencies.
We don't we do track DAGs. Well, we use the DAG ID and the task ID to name the job. Okay. So that's how you could do the relationship. But in Marquez, it's not aware of a DAG just because the entire lineage graph is a DAG.
Okay,
that makes sense.
So we do store jobs in a hierarchical fashion. So a specific job run can have a parent job run.
Okay.
And so when so we actually will post a run ID for the DAG itself. And then there will also be a run for the specific tasks. And then in the case of like Spark, for example, if the Airflow task is to kick off a Spark job, that Spark job will be a new job run, and its parent will be the task that kicked off that Spark job. And then even within the Spark job, you have DAGs, and each execution within the Spark run will have its parent as the Spark application.
Great. Okay, that clarifies that comment for me. Thank you. So, and the reason I like this is because I have not figured out how you do the tracking, but if the same file that is generated by one DAG is used as inputs from other DAGs, I would want to figure that out automagically, perhaps. Mm-hmm. And that would be the biggest value for us from my user base point of view, that who's using my output file.
Yeah.
Yeah, and then in terms of the questions about the data sets, again, right, so it's going to be dependent on the specific processing engine that you're using to generate or consume those data sets, which is kind of why I asked. In the Spark implementation specifically, we do post the data sets as the path to the file. We stop at the directory level. We don't include the individual files because oftentimes in Spark jobs, you're reading thousands of files, and we don't create thousands of data sets. Yeah, so if you're using a different processing engine, and if you're writing this integration yourself and it's a custom integration, you would just post the name of the data set as the path to the file or the path to the folder where the data lives. And then when reading that data, you would post the same data set name, again, the path to the folder. We don't have a way of supporting like aliases or logical relationships between data sets. So for example, if somebody writes to a folder in S3, and then somebody else has a Hive cluster that's set up to read from that same folder, but they call it, by a table name in the Hive metastore, we don't have a way of linking those two together at this point. But as long as the data set names are the same, then we'll be able to create that link in the graph.
And do you also look at the data within it? Is it at any point, or it's not? How do you generate the schema, or who generates the schema?
So again, that's dependent on the client itself. In Spark, we get the data set schema from the logical plan. We never actually look at the raw data itself.
Okay. Yeah, and similarly for the Airflow integration, what we have is if you're using a operator that interacts with the database, the integration actually says, okay, this is the once I parse the tables, for each individual table, it goes out to the database and fetches the schema, and then registers it with Marquez. So, Marquez is not going to inspect your data in any way. It's just going to say, whatever you tell me, I'm going to store it, and I'm going to apply some versioning function on top of that. Yeah.
Thank you. It's going to be a challenging project. I get excited and also get this thing about, I want to create a user interface for it where somebody can answer these questions without necessarily knowing JSON or jQuery or anything to answer these things.
So I'm wondering, are you part of our Slack channel?
Yes, I am.
Great.
Yeah.
So as you're kind of experimenting and trying to gather details about how you want to develop this tooling, we're more than happy to answer questions and how Marquez can fit in that solution that you're trying to build.
I did download the first version, but today when you showed the interrelationship, it helped because I was trying to play around with that. I couldn't follow it much, but I would love to use that. Yeah. Thank you, guys. Thank you for your time.
No, thank you for the questions. They were great. Okay, well, I think that's all we had, and really great to see new faces. You know, every month new people join, and it's always interesting use cases that they tell us about, and we're always happy to help. So it's awesome to hear these questions. But really, that's all we had, and the next community meeting will be next month, as we do these monthly. But throughout that time, please reach out to us on Slack or on Twitter, and we'll be happy to respond back.
Cool. Thank you.
All right. Well, thanks everyone.
Thank you.
Yeah. See you next time. Bye.